Okay, I'm going to work some of the problems from your homework on Algebra 2 Honors 2.4, numbers 3 to 47 odds. Here are some of the ones that were asked. The first one is the sum of two cubes. To do the sum of two cubes, you need to know the formula for that. So the formula is a to the third plus b to the third. And what that's going to equal is a plus b times a squared minus ab plus b squared. So I need to write these as cubes. So what cubed is 125? 5. What cubed is n cubed? N. And I believe 6 cubed is 216. So would you agree that A is 5n and B is 6? So A is 5n and B is 6. If A is 5n and I square it, you get 25n squared. Minus, because that's part of the formula, A times B. 5n times 6 is 30n. Plus b squared. If b is 6, 6 squared would be 36. So this is going to factor to 5n plus 6 times 25n squared minus 30n plus 36. And that's as factored as you can take it. If you use your sum and difference of cube formulas here, that last trinomial will not factor. If it did, I'd factor it in the formula for you. However, number 25, like most trinomials, factors into the product of two binomials. So to get a to the fourth, it might be a squared times a squared. I'll point out that these are expressions. There's no equal sign in this. That means you cannot solve them. You can only factor them or simplify them. Here I'm looking for the factors of a times c that add to give me b. And I believe it would be 6 and 1. Okay, I think the numbers would be 6 and 1 because 6 times 1 makes 6 and 6 plus 1 makes 7. Because a is a 1 here, you can simply put them right in, plus 6 and plus 1. There is no formula for the sum of squares. If one of these was the difference of squares, it might factor further. But because they're the sum of squares, you can't take them any further than this. Okay, I was also asked 33. Notice this is an equation. 33 you can actually solve. So to solve it, I'm going to make it equal 0 by subtracting 50x from both sides. Now the right side is going to equal 0. On the left, you're going to have 18x to the third minus 50x. Now I'm looking for something I can factor out of both of these. I know I can take a 2 and an x out. 2x times what is 18? Well, 2 times 9 would make 18. And to make x to the third, you'd need an x to the second. 2x times 25 makes 50. So I have 2x times the difference of squares. Because they're both squared and subtracted, it's going to be the square root of 9x squared, which is 3x plus, and 3x minus the square root of 25 is 5. So now I have it completely factored after I have it equaling 0. You need to make each of these factors equal 0. It's called the zero product theorem. If two things, or in this case 3 things, are multiplied together and equaling 0, at least one of these has to equal 0. So if 2x equals 0 and I divide by 2, one of my answers is x equals 0. If 3x plus 5 equals 0, I might subtract 5 and then divide by 3. and I'd have negative 5/3. And if 3x minus 5 equals 0, and I added 5 and divided by 3, you would have 5/3. So the answer would be 0, negative 5/3, and positive 5/3. Notice the number of solutions, the maximum number of solutions corresponds to the degree of the polynomial. Excuse me, because the highest power is 3, that means there's at most 3 solutions. And in this case, there are 3. Okay, now in number 35, we're back to an expression. There's no equal sign. I cannot solve it like I did in 35, but I can factor it. It's not a trinomial that'll factor into 3 terms. It's got 4 terms. Whenever you have 4 terms, think about or consider splitting it. So I'm going to split on the left, I'm going to take out an m squared. If I take out an m squared, that leaves me with m plus 6. On the right-hand side, I'm going to take out a negative 4. And again, that leaves me with m plus 6. If you distribute, you'll notice you still get negative 4m minus 24. Now, do they both have m plus 6's in them? So if I factor the m plus 6 out, what would remain? The m squared and the negative 4. Now, does m squared minus 4 factor, are they both perfect squares subtracted? So you have the square root of m squared, which is m. One will be plus, the other will be minus. What's the square root of 4? 2. So here it is in complete factored form. Okay, I apologize. I guess I wrote this down wrong. This is an equation. This equals 0. So if this equaled 0, first I would still factor it, but now I would make each factor equal 0. So if m plus 6 equals 0 and I subtract 6, I get negative 6. If m plus 2 equals 0 and I subtract 2, m would equal negative 2. And if m minus 2 equals 0 and I added 2, m would equal 2. So again, there are 3 solutions to this problem because the maximum number could be 3. Okay, after 35, I was also asked 37, another equation. To make it equal 0, you have to move something over. So I'm going to subtract the 84z to the third to the left-hand side, making it equal 0. Basically, I subtracted 84z to the third from both sides. Now, you have to make it equal 0 to solve. What can I factor out of both of these? A 4, because 4 divides into 4 and 4 divides into 84. What's the smaller power of z? Z to the 5 or z to the 3? Smaller power is z to the 3. That's why we factor it out. It's called factoring least powers. 4z to the third times what is 4z to the fifth? Looks like it would be z squared, because you add exponents making z to the fifth. If you factor a 4 out, you get a 21, and you took the z out. Is that correct? 4 times 21 is 84. You took out the z to the third. So now I'm going to factor it perhaps a little further because this is a difference of squares. You may not recognize it as one, but it is the difference of squares. It's just that the square root of 21 is not an integer. It's the square root of 21. So you make this equal 0, make this equal 0, make this equal 0, and you get z equals 0, z equals negative radical 21, and z equals positive radical 21. So you could probably write it this way to represent the 3 different solutions. 39, how many terms are there? 4. So you might think about splitting it. What can I take out of the first two? I can take out an x to the 4th. That leaves me with x squared minus 4. On the right, I think I can take a negative 9 out. That also leaves me with x squared minus 4. Again, when you distribute, you get you get x to the 6th minus 4x to the 4th minus 9x squared plus 36. So it is equivalent. Do both of these contain an x squared minus 4? So I factor that out. Times what remains? X to the 4th minus 9. Now this factors as the difference of squares into x plus 2, x minus 2. This will factor into x squared plus 3 and x squared minus 3. Only one of these could factor further, the difference of squares here, but we could set each of these equal to 0 right now. If that equals 0, you'd have negative 2. If this equals 0, you'd get positive 2. When you set x squared plus 3 equals 0, what happens? You subtract 3 and you take the square root and you'd have positive or negative I radical 3. We learned about imaginary numbers a little bit, did we not? I's. Now, don't worry. You don't have to do that. We're only dealing with real solutions, so I would not worry about that one. However, x squared minus 3 might equal 0. Add the 3 over, take the square root. If you take the square root in an equation, you get positive negative 3, the square root of 3. So there's 4 answers, positive negative 2, positive negative radical 3. Because there's 4 answers, the highest power, the most answers could be 6. But in this case, there's only 4 real solutions. Okay, 39, I was also asked 41 and 43. This is 3x to the 4th. I want to subtract the x to the 3rd to the other side to make it equal 0. So what does that leave me now? 3x to the 4th minus 1x to the 3rd minus 27x to the 2nd plus 9x is going to equal 0. Again, 4 terms. I'm going to take an x to the 3rd out of the left. If I take an x to the 3rd out, it looks to be 3x minus 1. Would that give me 3x to the 4th minus x to the 3rd? Over here on the right, I'm going to take out a negative 27. Again, I think that leaves me, actually, I'm going to take out a negative 27x. That also will leave me 3x minus 1, because that's negative 27x squared, and that's plus, I'm sorry, I don't want to take out a 27. What do I want to take out? Out of those two, I can only take out a 9. Is that correct? But I can also take out an x. Does that look better? Okay, if I take out a 9x, what would be here? 3x, hopefully minus 1, right? Does that work out? Is that negative 27x squared plus 9x? Yes. Now, what do both of these have that could be factored out? A 3x minus 1. If you take a 3x minus 1 out, what remains? X to the 3rd minus 9x. What can you factor out of those two? You can take out an x, can't you? Would that leave you with x squared minus 9? I just took an x out of both of these. Now, would that factor again? 3x minus 1 times x plus 3, x minus 3. I think that would factor as the difference of squares. Make each of these factors equal 0, And you're going to get your answers to be 1/3, 0, -3, and +3. You get that, like I say, by making each one of these equal 0. Add the 1, divide by the 3. For 43, we're back to expressions. So I'm going to factor, there's 3 terms. The trinomial usually factors into the product of 2 binomials. To get n to the 4th, could it be n squared times n squared? What multiplies to -60 but adds to -4? What would it be? -10 and 6. That multiplies to -60 and it adds to -4. Because a is a 1, I can put them right in. -10 plus 6. I believe that's the answer they're going to give you. The only thing you might do is factor this further because it's plus radical 10 and minus radical 10. But I don't think they're requiring you to do that for complete factorization. Let me check 43. No, they leave it as I have it boxed in, so you don't need to do this. Okay, on to the last couple, 45 and 47. Looks like I'm doing most of the homework this time. 4 terms, split it. What can I factor out of the left? Well, 3 goes into both and then a squared, right? So I'll take out a 3a squared. That leaves me with 12a minus 5, I believe. Over here, what am I going to take out? A positive 5, I know. Anything bigger? 7. Does 7 go into 84 evenly? 7 goes into there once. 7, 14, 2. So 7 times 12. So that would be 12a, and I'm assuming minus 5 is 7 times 5, 35. Okay, so we have this right. They both have what in them? 12a minus 5s. Can I factor that 12a minus 5 out? If I do, it's going to be times what's remaining. If I get rid of these, what's left? 3a squared plus 7. And I don't think that can factor because there's no rule for the sum of squares. So that would be your answer for 45. And 47, notice, is not 4 terms. It's 3 terms called a trinomial. Trinomials, again, factor usually into the product of 2 binomials. 2d squared times d squared would make 2d to the 4th. What's a times c on this one? 2 times -45 is -90. B is what? -13. Can you think of anything that multiplies to -90 that adds to -13? Negative what? 18 and 5. That's 50 and 40. So that's now multiplies to -90. Do they add to -13? Looks like they do. Because a is not a 1, I can't put them directly in there. You got to connect your outsides and your insides. So where am I going to put the 18, the -18? With the 2, because 2 goes into it. So I say 2 times what is -18? Let me say it again. 2 times what is -18? And that would be a -9. 1 times what is 5? Basically, there's a 1 times what is 5? 1 times 5. So this stays 2d squared plus 5 because you can't factor the sum of squares. But you can factor the difference of squares. So that would factor to d plus 3 times d minus 3. And that's the answer for 47. I hope these help. Good luck.